This is my explanation for the first algorithm or project in our final um, down. I guess this is my main method. I went ahead and used the same values that were provided in the example on the final assignment, and basically all I'm doing is, or this is just like calling the helper methods and stuff, but here I'm asking the user to input the value that they'd like to find in the list. And then once I have that, I get the index where the like value starts. So if if this is the list and we're looking for 5, it will give us this index, which is 4. So 0, 1, 2, 3, 4. And then I will get the last index of this 5. So 4, 5, 6, 7, 8, 9. So we'll have 4 and 9 as our indices that we'll get for the beginning and the ending. Down here, I basically take, or I am just taking the difference of those indices and using that to display how many occurrences there are in the list of that number. So I did set my helper methods, the get start index and get end index, what they call returns -1 when the value is not found. So in that list at all. So here I'm just checking to see if the beginning and ending indices are value -1. And if they are, I'm going to be returning 0. And if they're not, I'm taking the difference and adding 1 so that the number is inclusive. Otherwise, the number of occurrences are less than they should be if I don't add this 1. That's basically it. So here I just have a conditional asking, if the number of occurrences is 1 or not, just so that the output is accurate as far as plurality goes. And that's it for that part. The harder stuff is up here a little bit. I kind of like use the get and end index methods as wrappers around just the get index function. I made that a little bit more dynamic. Just it seemed easier, but I liked having the naming convention so it's really clear what I'm doing. The difference between these two methods is basically this like -1 and 1 that are being passed in. When we go up to the get index method, you'll notice that I'm using these values to like compare the current value either to the left or to the right of itself, just to make sure it's either the first occurrence or the last occurrence of that value. So these are really simple, and that's all they're doing. They're just calling this method up here, which is a lot larger. So we'll start at the top. Here I have I'm passing in like the beginning and ending index and everything. And this, I'm calling it well, it's supposed to be like relative compare index. So like if it's -1, then the relative index would be the one, the spot previously, and if it's 1, then it'll be this like index afterward. So that's why it's relative. Here I'm just getting the like index and the values just to make it a little easier to read later. So the first thing I do is get this middle index, so the spot in the middle of our range, and then the value of that, because ideally we would find the value we're looking for in the middle. And if not, then we, cut the array in half and continue down either side depending on where we need to go. This is basically, I guess, the algorithm's a little simpler when we don't have duplicate values, but because we do, we have some like more confusing logic happening. The ideal case is that, to return an index, we have, no matter what, we have to have the middle value equal the value that the user is requesting. So if the user is requesting 5 and the middle value is 5, then we would ideally return the middle index. But in this particular case, we have to ensure that the value to this whatever side we need is not the same as that value, because it might not be the first occurrence or the last occurrence. So that's where this extra conditional comes into play. We need to know if the index that we're comparing to is within the range that we care about. So, like if we are looking at a middle value, but it's actually the first place in the array, then the value to the left of us isn't relevant because it's not even in the array. So it would have an index of -1. So it's kind of an edge case, but also we really only care about what range we're looking at. So that makes the most sense. So basically, so this portion is if the compare value is not in the range, so we don't really care about it, and the middle value is the value that we're looking for, then we want to return this middle index. And the second portion of this is if the compare value is in the range and the middle value is the value we're looking for, and the middle value does not equal the value that we need to compare to. So it's either going to be the value on our left of the middle range or the right. So depending on the case, it'll either be the beginning occurrence or the first occurrence of the value or the last occurrence. And in that case, then we also want to return the index of the middle value. So that's like the ideal case when we pass in a value that will eventually at least be the middle index. Then we move on to this. It's like a base case. So this is when there are not any elements found matching the value that was, requested. So that's when the beginning index and the ending index are equal to each other, or they don't work at all. And that's just -1, and we check for that in the this main function below. So, and print out 0 as the number of occurrences for that value. So down here we have a little bit more complicated logic again. Again, just because there are duplicates of values in our array. The traditional case would just be to check and see if the value is greater or less than the middle value, and that's just, I guess that's actually like this whole statement. So we basically split the array in half and only search within our range when we want to like continue the search, like if that middle value was not equal to the value that we were looking for. And this is standard and expected. This first one is the special case, and that is basically when the two values next to each other, the value that we are looking at in the middle and the value either previously or after, whichever side it falls on, when those two values are the same, then we have to have kind of special logic, because it's not like very straightforward if we should be looking to the left or the right of that middle value. So here, instead of writing two separate functions, I'm using this like relative compare index that we're passing in, which is either 1 or -1, to determine if I should be moving left or right. So I think it was, I had -1 right to get the start index. So that's because we have to compare the index prior to us to make sure that it is not the same value to get the start index. So if I add the value plus the relative compare index, then I have a value that I can use to compare and say if we need to move left or right, because this changes the value by 1. So if our value that we're looking for is 5 and we want to get the the first occurrence of 5, then we have 5 plus -1, which is 4. So that way we can kind of like fudge that number a bit, because we still, we don't really need it to be like less than or equal to the number itself. So that's just using our special case to decide if we're moving left or right. If relative compare was 1, which is, we're looking for the end, then we would have 5 plus 1, which is 6, and we'd compare that to the middle value. So we'd have 6 is greater than 5, and if 6 is greater than 5, then we would go right. So we'd take the right half. Yeah, that's basically it. It's just an awkward special case. And then down here, we're just changing the beginning and middle indices depending on if we need to look in the left-hand side of the range or the right-hand side. That's basically it. That calls this method again, and we continue looking at the middle value until we get to our ideal case of having the beginning or ending occurrence of that value. So that's it.